6 on page 64 and 65. Put it in your table of contents, please. Okay. Title this area of regular polygons. Okay, here's the theorem 11.11, area of regular polygons. It's area equals 1/2 AP. A is the apothem, and the P, capital P, is the perimeter. And what I usually do is A equals AP divided by 2 is usually what I do. But oops, that's supposed to be an M. Apothem. Apothem is the perpendicular one, and then the perimeter will be the number of sides times the number of will be the side length times n being the number of sides, or the integons right there. There's the n for integons. Okay, so if I go to the first example here, example 1, it says, okay, if you're given this picture here, if I zoom in, so give me a minute. Okay, on this one it has the hexagon, which means it's 6 sides, is inscribed inside the circle. It says find each angle measure. The first one, EGF. EGF is the entire angle, which is a central angle. So the way to find that is to take 360 and divide it by the number of sides, 1, 2, 3, 4, 5, 6. So you divide by 6, and that means it is 60 degrees. Is that first one is 60 degrees, and that would be the first one. The second one, EGH, is half. So you take 60 and divide by 2, which means it's 30 degrees. So you take that one and divide by 2. That gives you 30. And then to get the other angle, HEG is the other side. Notice this is a right triangle. So if that top angle is 30 and this is 90, that means that other angle has to be 60, because this is creating a 30, 60, 90 triangle. If I look at it, example 2, the first one, it says find the measure of the central angle of the regular polygon given the number of sides, round it to the nearest 10th degree if it's necessary. So I take the 15, so I do 360 divided by 15, and when I do that calculation I come out with the central angles being 24 degrees. If I take the 32 degree sides, so I take 360 divided by 32, and when I do that calculations I get 11.28, so that rounds to 3 degrees. So 11.3 degrees. And that's always how you find the central angle of that shape, is do 360 divided by the number of sides. Using that idea for example 3, now we're going to actually find the length of the apothem. This is a regular octagon, which means it's 8 sides, has a radius that is 11.5. If I draw an octagon as best as possible, it says the radius is 11.5, so that means from a vertex to the center is 11.5. So if I draw a line straight down, I create the right triangle that I'm looking at. It wants to know the length of the apothem, which is this line from the center perpendicular to the side. So I'm going to put a little A for that side. That's the apothem. Now, to find that length, I need to know this angle at the top. Now, that is why we're doing examples 1 and 2, is to say I want to be able to find this entire angle by taking 360 and dividing it by the number of sides, which we said there was 8 sides. That gives me 40 degrees. No, I'm sorry, not 40 degrees, but 45 degrees for that entire angle here. But then I only want the right side of it, so then I'm going to divide it by 2, and when I do this, I get a decimal of 22.5 degrees. So actually what I'm looking at, I'm going to draw a larger right triangle, which symbolizes that triangle right there. And then I'm going to say that this was 11.5. This angle at the top is 22.5, and I'm looking for this side with this being a right triangle. Now, knowing two sides and an angle, that my only option here is to use my trig ratios, the SOHCAHTOA. And if I label the 11.5, this is the hypotenuse, and the A is my adjacent to this angle, so that means I'm going to use the cosine of 22.5 is equal to A over 11.5. So that means I can find A when I cross multiply. Right there will be 11.5 cosine of 22.5. Now remember, you got to make sure your calculator is in degrees when you do that calculation. And when I type it in, I find that the apothem is going to be 10.6 inches, because I am rounding to the nearest tenth. Okay, I'm going to change my page. I'm on page 65 now. This will be example 4. And it says, okay, I have a wooden coaster. It is a regular octagon. Octagon means it has 8 sides with the 3 centimeters on that side. And there's a little symbol there saying that it's 3 centimeters. It also tells me that the radius is about 3.92, which they have also drawn on the picture. What is the area? Now, the area formula that I'm going to be using is AP or PA divided by 2. Well, to find the P, I know that one side is 3 and I have 8 total sides, so that means my perimeter is 24. I need to find the apothem, which is a little a, and to be able to do that, I'm going to draw a right triangle over here on the side, a little bit bigger so I can actually see what's going on. The hypotenuse is 3.92. This entire side, if I was to draw the entire edge all the way across, would be 3, so half would be 1.5, and I'm looking for the apothem. Now, since I do know two sides, I can use Pythagorean theorem in this problem. And if I use Pythagorean theorem, that means I'm going to have a squared plus 1.5 squared equals 3.92 squared. .5 squared is 2.25, and 3.92 squared is 15.3664, and I want to subtract those values and end up with 13.1164 is equal to my a squared. And get rid of that squared, I'm going to take the square root of that number now. Means that the apothem is 3.62166 if I round way out there on the end. I'm going to take this back to my problem over here, and I'm going to put 3.6217, but realize I'm going to use everything in my calculator. So if I show you my calculator screen, I'm going to take that value, multiply it times 24, and come out with 86.9197699. It's because I'm filling in my perimeter. And then I'm going to divide it by 2. So my calculator, I'm going to hit divide by 2, and I end up with 43.5 centimeters squared is the area of my coaster. Make sure you use all of the digits in your calculator and don't just use your rounded answers when you come out into your problem. Be careful of that. Okay, on example 5, we're going to use the same pattern. It says a regular nonagon. Nonagon means there are 9 sides inscribed in the circle with a radius of 5. And if you notice, LK is labeled 5 or LJ is labeled 5. It wants us to find the perimeter and the area. If I look at the triangle a little bit bigger, I have a 5 on the outside, and that's the only thing I know. So I've got to find this angle at the top. And I can do that by saying 360 divided by the number of sides, which they said there was 9. So I'm going to divide by 9 and end up with 40. Now that's the entire side, so I have to now divide by 2 to say that that top angle up here is 20 degrees. Knowing that information, I'm looking for the apothem as well as the opposite side. So if I'm first finding the perimeter, straight across from the 20 is the opposite and the 5 is my hypotenuse, so that means I'm going to use the sine ratio of 20 equals, I'm going to make that actually an x because that looks kind of funny with an s there, over 5. So that means x will equal, 5 sine of 20. This equals 1.7101 and on and on and on and on. Now that's only half of it because this splits it into 2 small triangles, so I actually need to double this in my calculator. So I'm going to multiply it times 2, which means a side of my nonagon is about 3.420. To find the perimeter, I'm now going to take that number and multiply it times 9. I put an S there, meaning that number in my calculator, I'm going to multiply it times 9. And that means my perimeter is 30.8 units. That answers one of my questions. The perimeter is 30.8 units long. Now realize I'm keeping that in my calculator. I don't want to lose it. If I go back to my picture, I now need to find the A so that I can calculate the area, because remember your area is PA divided by 2. Now I can either go back to my trig, which I'm going to do that on this one just because of my strange numbers that I had starting out with here. And the A is beside it, so that means it is the adjacent. So that means I'm going to go to the cosine of 20 is equal to A over 5. So I can find out that the apothem is 4.6985 if I rounded on the 5. So I'm going to take this number for my area formula. I'm going to take the perimeter number and multiply it times the area number and then divide it by 2. Okay, so if I blow this up just a little bit, my calculator, I have the area, I'm sorry, the perimeter already given to me. I'm going to multiply it times the apothem, which is there. I get 144, and then I'm going to divide it by 2, and it tells me my area is 72.3. And that would be units squared for the second answer there. Okay, here is example number 6. Find the area of the shaded region, answer it to the nearest degree. So what I'm given here is that a side is 12. So if I draw a right triangle on here, I know that this little piece down here is 6, and I've got to find that angle. The only way to find that angle is take 360 and divide it by the number of sides, which is 5. 360 divided by 5 is 72, and then I've got to divide it by 2, which gives me 36. So I know that angle right there is 36 degrees. I need to find the apothem, so that means I'm going to do opposite over adjacent, which is your tangent ratio of 36, is equal to 6 over A. And I'm going to cross multiply and then divide, so that means the A is actually going to be 6 divided by the tangent of 36. This is the one that flip-flops because of where it's at. I'll type that in my calculator. It shows me that A is 8.2583 if I round way out there on the end. Now I also needed to have found the perimeter, which was 12 times the number of sides, which is 5, which means the perimeter was 60. To do my area formula, I'm going to do perimeter times the area divided by 2, or perimeter times the apothem. Sorry about that. So I'm going to take that number, it's in my calculator, right there, multiply it times 60, and then I'm going to divide that by 2. It's going to be 247.7. And they don't give me units, so that's units squared is my area. Alright, here we go. Last example, number 7. Just to show you we're repeating this pattern over and over and over. On our last example, the 9 represents our apothem, so they already given us that info. So for my area, I already have the little a, but now I got to find the p. To find the p, that means I have to find this little piece of that side first, and then I'm going to double it and then multiply it times the number of sides. So if I look at that triangle a little bigger, I need to find that top angle, and the only way to find that top angle is to start by doing 360 divided by the number of sides, which this is a 1, 2, 3, 4, 5, 6, 7. This is an 8-sided shape, so that means that is a 45-degree angle. And then I have to divide it by 2, which means this is 22.5. Now I want to find the opposite side, which means this is opposite and adjacent. That's the tangent ratio is equal to my opposite over my adjacent. So to find that opposite side, I'm going to do 9 times the tangent of 22.5. That gives me 3.7279. And now I've got to double it to get the entire side length. So that means each side is roughly 7.4558. Now to find the perimeter, I'm going to now multiply that times 9 because there's 9 sides. That tells me my perimeter is 67.103. Now I'm ready to go to my formula because I have the perimeter given to me. I know my apothem is is 9, so I'm ready to do that number times 9. So I'm going to take that number, multiply it times 9, and then divide it by 2. Oh, I messed up. Hang on. I just saw it. I don't have 9 sides, I have 8 sides. So I'm going to take that 745 and I'm going to multiply it times 8 to see that my perimeter is actually 59.6467 roughly. I'm going to take that number and multiply it times my apothem, which is a 9, and divide by 2. Okay, so here, let me get that on my screen so you can see it. There you go, so 59.646 times 9, the apothem, and then divide that by 2 gives me 268.4. And that would be units squared. Okay, if you were understanding this pretty good, give me a smiley face. Or you could give me a thumbs up if you don't like smiley faces. Whoops, I can't draw a thumb very well. If you are not understanding this and need me to sit down with you and explain a little more, then give me a frown or down arrow or something to symbolize as you're not quite understanding this.